Hey students, this is lesson 12.4, angle measures and segment lengths. In this lesson, we're going to learn how to find the measures of angles formed by chords, secants, and tangents, and to find the lengths of segments associated with circles. Go ahead and do the review here, and I'll check back with you. All right, some theorems we're going to use. The measure of an angle formed by two lines that intersect inside the circle is half the sum of the measures of the intersected arcs. And theorem 12.14, the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. So the big arc intercepted minus the smaller arc intercepted, half of that. And then 12.15, for a given point in a circle, the product of the lengths of the two segments from a point to the circle is constant along any line to the point in the circle. So basically the distance from that point to the circle is the product of those distances is constant. Go ahead and try doing 9 through 16, and I'll check back with you. All right, let's use those theorem here in problem 1, finding angle measures. What is the value of each variable? In this first one, we're going to use theorem 12.13, which says that an angle inside a circle, such as x, is equal to 1/2 the sum of the intercepted arcs. So x is equal to 1/2 87 plus 165, and that's equal to 1/2 252, which is 126. And the second problem here, we're going to use theorem 12.14, and that theorem says that if the angle occurs outside the circle, then this angle here, will be half of the difference between the two intercepted arcs. So this arc minus this arc. So 22 is equal to 1/2 of 98 minus y. And then simplifying that, we get 49 minus 1/2 y. Subtracting 22 minus 49 gives us negative 27 equal to negative 1/2 y. Multiplying both sides by negative 2 gives us y is equal to 4. All right, you try that. All right, here we have a problem. It says the viewing angle of the moon from the spacecraft is formed by two tangents to the moon. The viewing angle is 18 degrees. What is the measured degrees of the arc of the moon that is viewed? So I'm just going to create an angle like that. And so our spacecraft is right here. Let's just call that S. And then the moon is over here. And the arc of the moon, that's not quite right. We need a circle for that. And that circle should fit inside there. Like that. And then this arc is the viewing arc that we're talking about here. Now S is 18 degrees right there. And one thing we know is that, let's just label this X and this Y. Then 1/2 of Y minus X is going to equal our angle there of 18, according to theorem 1214. And we also know that Y is equal to 360 minus X, because the two angles have to add up to 360, the number of degrees in the circle. So I'm just going to substitute 360 minus X for Y, and I get this equation. 360 minus X is equal to 18. I'm going to simplify here. I'm going to multiply both sides by 2 and simplify. Inside here we get 360 minus 2x is equal to 36. Then if we subtract 360 from both sides, we get negative 2x is equal to negative 324. Dividing both sides by negative 2 gives us x is equal to 162. So our viewing, so we can view 162 degrees of the moon from that position. All right, you go ahead and try one of those, and I'll check back with you. All right, finding segment lengths. To do this, we're going to use theorem 1215. And that theorem says that we have a constant product from this point to the two places that it meets. If we multiply those two lengths, so that blue line multiplied by this red line will equal this blue line multiplied by this red line on both of those. So there's a constant product there. So 14 times 11, or 14 plus 11 times 11 has to equal 12 plus x times 12. And if I simplify that, I get 25 times 11, which is 275, is equal to 144 plus 12x. Subtracting 144 from both sides gives me 131 is equal to 12x. And dividing both sides by 12 gives me about 10.9 for x. In the second one, the same deal, but since it's a tangent line, the two distances are the same. So we have, in this case, we're going to have a squared is equal to this total length here, which is 9 plus 6, so 15 times the shorter distance, right there, 6. So a squared is equal to 90. So a is equal to the square root of 90. If we want the exact amount, we would just simplify that and we get 3 times the square root of 10. Or if we want to approximate that, it would be about 9.5. Go ahead and try that. All right, that does it for lesson 12.4. Go ahead and try the lesson check, and we'll talk about this next time in class.